Today, being an engineer is very exciting. We're going through an energy transition. We have new computation, new classes of automation and robotics. Hardware and software are back. At the same time, what's happening in medicine, precision agriculture, carbon reduction. All of these transitions are happening, which means that there's so many new combinations, new opportunities that rising engineers can address. STM is a program in the graduate schools of engineering and the Sloan School of Management at MIT. It offers both a master's degree in engineering and management as well as a certificate in the same. Our students are at mid-career. We have students from agriculture, from energy, biotech, health, aerospace, from automotive, from governments and military in one classroom. If we looked at curriculum a century ago, each of the separate disciplines was establishing their own first laws and their own disciplinary principles. Today, the engineering problems we're working on are connected. That is, we can't separate the subsystem we're working on from the system it connects to. And that connected system lives in an ecosystem that includes other systems. So an engineering leader now not only must help coordinate and make trades amongst the engineering disciplines, but we must be capable of also interacting, having dialogue, having conversations with stakeholders, economists, regulators, lawyers, sociologists, ethnographers. So that becomes a central part of what an engineering leader for complex systems problems must deal with. But let's start with the core, because the core is really unique. We teach this class over 9 months. With every few weeks, we spiral through system architecture, system engineering, and project management. These are 3 capabilities that an engineering leader, especially for complex modern projects, has to have. Students are involved in hundreds of hours of activity, including 300 hours of team-based projects. We invite outside organizations, both companies and governments, to propose a problem. The students begin by simply trying to frame the problem. They then take that and understand it and decompose that system and understand how it might perform and function with different options and different approaches. And then they also think about what it means to then take this proposed system into the real world. The significant peer learning. Then there's also now a new vocabulary, a new way of seeing the world as systems, and a whole toolkit of methods that people learn. After the core, there are foundation classes tied to systems, both in engineering and in management. It's also now important, heading towards a thesis, to explore. While at MIT, it's such an amazing place. It's like being a kid in a candy store. There's so many interesting classes, interesting activities. And so the electives give one a chance to shape one's own degree. And thesis is an important ultimate expression of the journey they've been on as a student, advised by a faculty member or a professional researcher. And typically it's a one-on-one dialogue over at least 6 months. What's always amazing to me is to see how a student evolves leading up to the topic in their thesis, which could be groundbreaking, maybe something they could never have anticipated when they entered. And an important part of the experience in being here at MIT is permitting that discovery, being open-minded, being diligent, interacting a ton, then allowing for the discovery and the shaping, whether it's a new technique, a new method, a new company that might emerge from the time here.